A manufacturer knows that their items have a normally distributed lifespan with a mean of 8.3 years and a standard deviation of 1.3 years. If you randomly purchase one item, what is the probability it will last longer than 8 years? So we're being asked for a probability. So that's the question that we want to answer. We are told that we're working with a set of data that is normally distributed. So that right there tells us that we can use normal distribution probabilities to answer our question. So start yourself out by sketching a normal distribution and put the pertinent information on it. So we need to know the mean and standard deviation of this distribution. So the mean is the center point of your distribution, and we're looking for the probability that something's going to last longer than 8 years. So 8 is lower than 8.3, so I'll just put it over here. But if we want it to last longer than 8 years, that is values that are larger than 8, so we would shade to the right. Now, to calculate this probability, we're going to use the calculator function normal CDF, which takes up to 4 inputs. And the inputs it takes are the lower bound of your shaded region, the upper bound of your shaded region, which in this case is technically positive infinity, but there's no infinity key on the calculator, so I always use E99, which just means 1 times 10 to the 99th power, so it's just a very big number. The last two inputs are the mean and the standard deviation of your distribution. So in this case, the mean is 8.3, and the standard deviation is 1.3. And this is very convenient because it will calculate the z-scores for you. And the nice thing about that is if you had to calculate the z-scores yourself, so if we took 8 minus 8.3 divided by 1.3, there's a lot of decimal values that we have to be careful of how we round, because anytime you round in an intermediate step, you can get a less accurate answer in the following steps. So allowing the calculator to do these for you is actually kind of helpful because it makes sure you get the most accurate answer. So here's what we'll do. Second in distribution, then grab the normal CDF function. Now, for me, normal CDF just comes up on screen. For some of you, you may see normal CDF bringing up a menu. And that's okay too. Essentially, it's asking for the same 4 items. So a lower bound of your region's area, an upper bound of the shaded area, the mean, and the standard deviation. And I'm going to type those in here. Lower bound is 8, upper bound, I'm going to do E and 99, so that means a very large number. Oh, and E is second in comma. Then 8.3 and 1.3 as my mean and standard deviation. Now when you hit paste, all it does is it puts back on the home screen the normal CDF function along with these inputs. So if you didn't have that menu, normal CDF would show up on the home screen, and then you would just type in these inputs separated by commas. So either way, it works just the same, and you get the same answer of 0.5913.